class website. I don't know if it's me or not.
You can't access the
But
class.
I used to access it by this page right here. It just keeps loading. I don't know if it's just me.
It just keeps loading.
Yeah, you have to go back to no. Oh, you have it open.
Might
Okay,
like
so it's
your
just me then.
cookies or something.
I
Like
didn't
you just
figure it
push
out.
something. That was.
So
It looks like others are not having trouble, so it might just be.
You broke it, Andrew. I think you may have actually. Like, that wasn't a joke. Like, I can't get on.
I didn't change that file.
I'm on my local, so Andrew's gonna help you because Andrew broke it.
I didn't break it. You didn't touch anything today.
Also, sometimes I think it was just working.
I just got into it.
All right, yeah. Sometimes.
Email.
So the other thing is our Wi-Fi in this building likes to play some fun tricks. So if you are on the secure network, sometimes the guest network can access things. So it's because our IT department has some fun things with it, like to block certain things at certain times for no apparent reason. So a lot of us, for example, have personal websites on things other than Option server, and like half of us one week couldn't access any of our personal websites. So I don't know. It should be fixed now. I can get on now. I don't know. Might just want to change the. Was it like just now, or was it like all of yesterday or something?
Kind of just now.
Okay. All right.
Check there your cookies or something.
Yeah.
Blame me for breaking it.
So it's definitely Andrew. So he just fixed it. He just fixed it right now, and he just didn't tell you that was really what happened. All right. So I'm gonna review. I don't think anybody has any problems, but I will be recording this lecture a bit to put up because I'm not seeing. I'm not sure if everyone either got the memo or it just seems like there's a few people missing. So I'm going to record the first kind of half of this lecture just in case they miss anything. All the other ones from the previous years are still online, but I just want to let you know. All right, data summarization. All right, so not surprisingly, R has pretty much a function for almost every single summarization thing you want to do. So if you want to calculate the mean of a vector, right, just the mean of x. You want to calculate the standard deviation, it says d. Median, right, any of the quantiles, right. So quantile x by default displays the 0, 25th, 50th, 75th, and maximum of a data set. Range just does the min and the max, right? So there are also, obviously, min and max. So sum takes the sum of x, right? So all of these have an argument called na.rm. So we're going to be talking about missing data a little bit later today, and all missing data is usually, almost always coded as na, right? There are different types of missingness. So there's NaN, which is not a number, which is what happens when you divide, the number 5 by 0, because that's undefined. Or sorry, that's infinity. If you divide 0 by 0, it's not a number, it's undefined, right? So there are a few other specific types of missing data or non-real data that this will remove, but pretty much by default, when you take any of these summarizations, right, the mean, the max, whatever, and there's missing data in there, R will return missing. So it pretty much does that as a safeguard to kind of inform you to say, hey, you have some missing data here. Are you aware of that? If you are, fine, and if you want me to calculate these statistics without those missing values in there, you just got to tell me to do that, right? So it's kind of like as though we said many times this week, R can allow you to do things that are seemingly pretty dangerous, right? So it allows you to add a vector of like length 4 to something of length 5, which to me seems pretty dangerous. But it'll allow you to do it. There are some instances where it kind of tries to safeguard you from disaster. So these are a lot of the standard things you want to do in table 1s and stuff like that. And it doesn't have like a summarization for proportion, but if you take the mean of a logical 0, 1 thing, that is just a proportion, right? And it has a whole bunch of other transformations. So some of them will be showing log, which is the natural logarithm, log 2, which is the log base 2, log 10, which is log base 10, SQRT for square root. And a lot of these are usually useful when you're doing histograms or some transformations of the data that's highly skewed, so you can kind of get an idea of what the distribution looks like. So again, we're going to be using the MT cars data set that we've shown you a little bit yesterday, or a lot yesterday. So I will say, although I use the dplyr verbs very heavily, right? So the filter, mutate, all that fun stuff. The $ is still used like all the time, everywhere, regardless if you like do dplyr or do this other kind of stuff. Like everybody uses like data frame $ variable name, right? So here we're just taking the mean horsepower, and the mean horsepower is 146 horsepower in that data set. We take the quantile. Again, it gives you the standard quantile output, and we can change which quantiles it gives us. So again, median, same thing. We want the median weight of a car. So I think it's 3 tons. And we say quantile, and the second argument that you can put in there other than the vector is the probabilities that you want to get. Which quantiles do you want to get? So I want the 60th percentile. So the 60th percentile for weight is 3.4 tons. All right? So we're going to be talking about testing a lot later, but if you wanted, for example, like a confidence interval of the mean, the t.test function is a very straightforward way to get that. So you take t.test, and you put in that vector again, and this is the output. So it says it's a one sample t-test. What is the data you put in there? This is the t-statistic, the degrees of freedom. This is the p-value. One thing that is a huge pet peeve of mine, p-values are never 0. It is impossible by their definition. So if and I'm sure you've seen the news over and over again, p-values being like the probability of seeing something as extreme or more extreme given the null hypothesis. You saw something that extreme. You saw it. Therefore, it has a non-zero probability, right? So just a quick aside, you always put p-values less than some value. You never say they're equal to 0. So statistician rant over. So it gives you the alternative hypothesis. So it's a 2-sided test by default. There are options to change that. It gives you a 95% confidence interval and the estimate of the mean. So we're going to talk a little bit later when we do the testing about this package called Broom. So Broom has this function called tidy, which if you apply that function to some of these testing things, or actually a lot of different objects like models and stuff like that, it gives you the results in a data frame or a tibble that is much more easier to manipulate, right? So all the verbs we've talked about so far, like filter, mutate, select, all that kind of stuff, they work on data frames or tibbles, right? There are other types of objects, which we'll talk about today, that aren't those things. So in order to get from those other types of objects into data frames, the tidy function in Broom is very helpful. Okay, so then you can use dplyr on all that stuff. So the guy who created Broom is this guy named David Robinson, who's really fantastic coder, and he works at Stack Overflow. He's not one of the RStudio folks, but he's another one who really makes really great packages. And his story is like, so he has a twin brother, and he was making this package, and he was wondering like what he had this function tidy, and he didn't know what to make it. He's like, well, you like tidy up a room with like you sweep, and so he made it called Broom. The problem with that is, the problem for me is there's a tidyr package, which we'll talk about today, and the tidy function is not in the tidyr package. The tidy function is in the Broom package. So kind of semantically, it's a little hard. But they are both in the tidyverse, so if you load them up, it doesn't matter. You don't necessarily have to know which package it's from. Again, if you load up the tidyverse, you don't have to say Broom : : you just say tidy, and it will work. Okay? All right, so missing data. So I'm going to just define, like, we say we don't use a lot of toy examples, but a lot of times they're better for illustration on simple things, right? So we just have a vector x. We have just a bunch of numbers, 1, 5, 7, some missing value, 4, 2, 8, 10, 45, 42. Let's say this is like the number of months of newborn children or something like that in your data set. And for some reason, for this fourth case, you don't have that value. You don't have it yet. Either it's not there for follow-up yet, or you just never got the initial baseline, or there's dropout, whatever. It's missing. So if you take the mean, you're going to get missing. right? And so conceptually, this is the way I like to think of it. Like, you don't know what that number is. That number could be 100. That number could be 0. Number could be like 4, right? You don't know what that value is. Therefore, you don't actually know what the true mean is, right? And that's the way I think R thinks in most respects, right? You take the mean of it. I can't tell you that. I can't tell you that value because I don't actually know the value of this. But in most practical cases, you want it to say, I want to take the mean of non-missing values, right? That's usually what you want to do. So you just say mean, and the argument na.rm, remove the NAs, is true, and it'll give you the mean of the non-missing cases. Okay? So similarly, so quantile is a little bit different in that all the other functions I showed you will just give you NA back. Quantile is the only function. If you have missing values in there and you don't set this true, it'll actually error out. So if I say quantile x and there's missing values in there, it says, I don't know what you're trying to do. I can't do quantiles with missing data. Either get rid of your missing data on your own or tell me to get rid of it in the function. Most times because for example, you may be doing the quantile on multiple variables, right? So let's say you have like 10 columns of variables you want to do quantiles on, right? Usually you don't want to subset only the data that has full data for every single case. There's biases for dropping out that data, right? So you want to do the quantiles for each one, and you want to remove the missing data when it exists. That being said, the quantiles for column 1 may be based on 100 observations. The quantiles for column 2 may be based on 80 observations if you have different numbers of missingness in there. So there's some other summarization functions that are really helpful if you want to do some things at a very, very large level. So col means, row sums, col sums. Taking an entire matrix or a data frame, we'll talk about exactly what a matrix is a little bit later, but it takes an entire data set and it computes the mean or the sum over every single either column or row. Summary is a good function. We're going to be using it a little bit later extensively when we make models. But summary on a data frame will give you some sort of summarization out that pretty much gives you the number of observations, the quantiles, and like the mean. Right? So some basic information that you'd want. I tend to not use this that much because I usually want one of those statistics or two of those statistics. I don't necessarily want all of them, so I usually would just specify. I would run whatever command I wanted myself on the specific columns I wanted, not on every single column of the data set. Also, especially when you have data frames that are very large, right? You have over like 10 to 20 columns, right? Seeing 20 summarizations at one time isn't very conceptually easy to kind of digest. All right, so we're going to jump over to the first part of the lab. So I think it's relatively short and straightforward. Let me download it. So I'm going to download. All right, so let's take about 5 minutes to work on this. So part 1 of the data summarization lab. And Andrew and I will be floating around so you can answer any questions.
Can I access the website now?
You fix
I
it.
do anything now.
Yeah, so, we're going to talk about a function called if else. So you can say if else, ELS.
Yeah, there's no key or there's no
Okay.
code book or anything.
Yep.
Let's pretend like the units are feet for that bike lane length, just so.
So, for example, let's also let's read our space. Let's try this. I'll start first. Whatever. So pretty much that one state previously seen but it's not something that's so you just need to take some so it's blank but it's
All right, so I'm gonna start the lab. So at the top, I'm just gonna load in the tidyverse package, just so I know I have readr, I have dplyr, all that kind of stuff loaded, so that when I go to read in this data set, I can say bike equals read CSV. I'm gonna put in the path on the internet. Again, remember read CSV can directly read from a data set online or CSV online. And so how'd you get the number of bike lanes? One function. One of them. So I heard n row for 1. So if you do sum on this, what do you get? Sum bike. I don't know if I think it'll error. So you can say dim bike, right? And that'll give you the number of rows, number of columns. You could also have looked at it in your environment or anything like that. You could do str bike, and it'll say a whole bunch of stuff, but it'll be say 1631 observations, 9 variables, and you could have also said glimpse bike, right? This is some other ways, and it'll show you that these are some of the columns. This is the type they are, and here, for example, date installed is an integer, length is a double, and so how many feet and miles of bike lanes are currently in Baltimore. So we can use sum, right? But we have to tell it that the column we want is from the bike data set. So we say sum bike $sign length, and then we divide by 1760. I don't know how many feet in a mile. I'm thinking of yards. Okay, yeah. So 83 miles of bike lanes in Baltimore. If you biked in the city, that's kind of surprising, because either they don't really exist or cars just don't care. But again, one of the big things, although we are using, we will show you today some ways to use this in the dplyr framework. So we're going to be able to say bike, and then we're going to use this function called summarize mean length in dplyr. So we haven't talked about summarize yet, but we will. So again, we could have done mean bike $sign length to get the mean feet, and then divided by 5280. We can also, in the dplyr framework, use the summarize function. Note, we will talk about the differences between these two again today, but this returns a tibble, this returns just a straight number, just a vector. And we'll be able to show you, there are some other nice summarization functions, kind of like we talked about, what was it, rename all. There are summarize all and some other functions that allow you to do large-scale operations on the entire data set. But is everything from here, is everything that I've done in these two questions pretty straightforward? Yeah.
I just did for the sum bike lanes $sign non-lanes, and I got, so what is that then?
So that is, so like so that's a little bit different. That's a variable, like the number of lanes in the lane, right? So if you have a bike lane that has 2 different lanes, it might say 0 or it's just something a little bit different with respect to the data. So if you we'll talk about this table. Oddly, there are some bike lanes with no lanes. So one of the lovely things of getting data from the city or the government is they just give it to you, right? As many of you know, especially working in public health, for example, sometimes you get the data sets and they don't make any logical sense, or at least some of the variables. So here's one indication, right? So either they don't know the number of lanes, so they put 0, which we don't know unless we have to go back to the source, or somehow you have a bike lane with no lanes. So that's what that's counting up. And that's why after we initially used this data set, we said just count the number of rows because that column makes no sense. All right. Any questions for going forward? For those who are just coming in, I am recording the first. I've recorded the first half hour, so if you didn't miss anything, I'll put that up online tonight. In case you thought you missed anything, pretty much we just went over the first couple of slides of data summarization. So we're going to read in another data set. It's going to be the TB incidence data. So this is the incidence in all forms per 100,000 population per year over a bunch of countries in the world. And so we have in our folder a data set that is called TB incidence XLSX. We're going to use the read Excel function again, and the data is formatted in a non-tidy way, right? So we have one column for the country, and then we have multiple columns for different years. So this is what I'll call a wide data set, and we'll talk about reshaping a little bit later this afternoon. So one, we're going to rename the first column to actually just the country. So the way this data is formatted is the first column. Here, maybe I'll just incidence. So the way the data is set up is as follows. So it's all these different countries for all these different years, and the first column kind of trying to tell you a little bit more information, which is good. It's the TB incidence, but that's actually not a good column name because that is not what that column represents. It represents the actual country. So what we're going to use is the rename function, and we're going to say country is equal to this really, really, really long thing. Note sometimes when you have column names in a data set that have, I'll call, they're not odd characters, but they're characters that shouldn't necessarily be there. So things that shouldn't be in column names. Dollar signs, right? Because we know how do you access a column name? The dollar signs. You shouldn't have a dollar sign in there. They shouldn't have spaces. They shouldn't have parentheses. They shouldn't have commas. This one has a bunch of those things. It can have underscores. It can have periods. Those are totally fine. It shouldn't have dashes, right? Dashes mean subtraction. So they shouldn't have those either. But when you read them in, when you read in a data set from read CSV, it'll try as best it can to keep the column name to whatever it was, and also in read Excel. Right? So this super long name, it didn't try to format it and change it or anything like that, so we're just going to rename it ourselves. But because it's got these weird characters, or these non-OK characters, that's why you see this little backtick here. So it's just saying, hey, this little backtick, which is at the top left of your keyboard under the tilde, it's just saying, I'm calling this a column name. I'm going to rename country from this really, really strange, really long, complicated column name. So now we look at the column names. We see, okay, first column is country. Then we have the year of TB incidence. So now we're going to take our dplyr function. We're going to select from this data set, from the TB data set, and we're going to use one of these modifiers, these helper functions, and we're going to say, I want any of those columns that starts with a 1. Right? So any of the data before 2000. Right? So it starts with a 1, and then we're going to take this data set, and we can use one of these large functions that can do large-scale operations, col means, to do the column means of all the data, and we want to remove any missing data points in there. And so we see in 1999, the incidence, or 1990 was about 105. It seems to have been going up steadily. But again, you have to understand that each column may have different numbers of observations. So some countries which may have higher incidence of TB may be reporting more later in those years. So also, we can take this data set and get the row means. Right? So the row means correspond to, in this case, the average TB incidence over the years from 1990 to 1999. Right? That's what the row means. So it's an average for each row. Right? And so we can actually assign that. We could have used mutate, but again, we can use that or the $sign notation where we say TB before 2000 average is equal to this row means, and now we put that onto our data set. So now we have a country, the data from 1990 to 2007, and also a column for the average before 2000. So for example, Afghanistan had an average TB incidence of 168 per 100,000 people over those 10 years. Okay. So again, summary on a data set, on a data frame, will do this summarization. Again, it's a little bit much to digest, but the one thing it does do well, it gives you the min, the quantiles, and the mean, but it also gives you the number of missing values in there. All right. So I think that's a little bit a little bit much to digest, but sometimes some people like it. We're not going to use apply functions. So apply is a general set of. Apply is a function that allows you to perform another function on your data over one of the margins, either the rows or the columns. So I just showed you col means, row sums, col sums. Right? You could do column standard deviations. You could do column maxes, column, I don't know, whatever you want. Right? Apply allows you to do that. So the way that this function is set up, you say apply the data set, the margin, and a margin, if it's 1, remember, R thinks in rows first, then columns. So because it's the subsetting is rows, columns. So the margin, if you set it equal to 1, it says do this over the rows. If you set it equal to 2, it does it over the columns. Okay? And then whatever function you want to apply. So for example, in this data set, if we wanted to do the standard deviations, or the means again, so here we say apply over this averages, we want to do 2, which is the columns. We want to take the mean, I'm going to say na.rm equals true. This is exactly the same thing we did with the column means function. So this is the column means again. Here, if we did apply averages 1 mean, we would have got the row means again. But again, we could put any function in there, like the standard deviation or the maximum. The only reason I'm just showing the head of this is because there's a whole bunch of countries. If I printed them all out, there'd be like 400 rows here. But here we're applying on this data set over the columns, the standard deviation, and we want you to remove missingness. Right? So although the means seem to be increasing, if we look, we also see a higher amount of variability over time, right? Looking at 110 versus 146. Again, as whatever data scientist or statistician nowadays, this is not how I actually see that, right? I would just plot this, but we're getting to plotting at the end of this, but just to kind of give you some idea of looking at some of the data. And again, if we're looking at the maximum, it looks like there is seemingly being this increasing max over the 10 years of this data. So, apply statements. So there are other versions of apply. We're going to maybe only touch on one of them, but just know that they exist. This is a good resource to understand exactly what apply statements do. There is t-applies, which allow you to apply a function over a grouping index, but that's not the recommended way. We're going to show you how to do that. There's going to be a function called group by, which allows you to do summary statistics, models, or whatever you want to do by groups. For example, if you want to group over patient populations or treatment groups or something like that, we'll show you how to do that. lapply applies functions to a list, and it returns a list. We'll talk exactly what a list is. So since the days got bumped, this is not tomorrow, this is today. We'll be talking about lists a little bit later. sapply applies a function to a list. The only difference between these two is it tries to simplify the results for you. So again, they're commonly used, and they'll be, if you've talked to anyone who's programmed in R for probably over 3 years, or even new users, they might use a lot of apply statements. But I think that you can do almost everything that you want in the dplyr framework, and we're going to try to show you how to do all that. If you want to do something else, we will, just call it out, and we'll try to show you how to do it. All right, back to the youth tobacco survey, right? So again, we have a bunch of data over a bunch of years for the states. So we read in the data set, we call it YTS. So it's smoking rates for males and females and overall genders for over a set of years, over a bunch of states and national levels. So one of the functions we're trying to show you here, unique, right? Unique on a vector returns the unique elements of that vector in the order in which they were given. So for example, if I say unique on the location description, it's going to give me all the unique values of that column. So here, Arizona, Connecticut, Georgia, but it also has, it has all the states, but it's also got the national level in that data set, for example. So length, I think we've talked about that. talked about the length of a vector. But when you combine it with unique, it'll tell you the number of unique elements. So we say length, unique, location description, right? It'll tell us the number of unique elements in this, right? So though it says 50, that should be a little bit worrisome because we know we have the national level in there, and this number is not 51. We're missing some state, right? So table's a very, very widely used function. We use it for single tabulations, cross tabulations. It's relatively straightforward. You put a vector x in there, you say table on that, and we're just showing you the first 5 elements of that. So it's just a frequency table. So there are 240 records for Arizona, 210 for Arkansas, 96 for California. And that could be because they just have varying numbers of estimates over the years. All right? Does that make sense? You'll be using table a lot in practice. All right, so we're going to move on. All right, so any questions before we start lab 2?
So unique won't show you duplicates, right? It won't tell you how many.
Nope.
It will just pick up the ones that are in general.
So the unique element. So there is a function called duplicated, which will tell you if something is a duplicate. So that's a little bit. So for example, let's say you had a vector that was Arizona, California, and all the rest of the states. The first Arizona would not come up true as duplicated. The second one would, so that it would say that one's duplicated, and then the rest of them, if they weren't duplicated, they would all come up false, right? But unique. So if you want to know also, so another way. So again, there's a lot of different strategies. If you did table on that, if you saw anything that's greater than 1 here, you know that there's more than one record with that value. All right, so we're going to part 2. So again, this should be relatively straightforward. Take about 45 minutes. And for number 3, we actually mean the column type. So there's a column named type in the data set. Column left. Yeah, we'll do one after. We'll do it after the lecture.
as you preserve the space around it, usually does it look okay. Yeah, there's not really a good way to do that in tables.
Okay.
That's where like Markdown is useful. Or not Markdown, so you can sort of print tables
In the report.
This function will not S max no S max. Yeah, that's why I'm just using Excel safer. So it figures out which one to use. It probably calls one of those functions based on the problem.
All right. So, how many types of bike lanes are there? 13. How'd you get that? All right, length.
Unique bike lanes. No, sorry, I'm looking at projects.
So,
No, types were 1, 2.
so I got 8.
Yeah.
8?
No, I'm looking at projects.
So,
7, 8. I did a table.
so tab, right? So we could say the length of the table says 7. What's going on here? So, if we say unique bike type, what do you notice about one of those bike types? It's missing. So it depends on what you mean. So there are 8 unique values in bike type, but when we do the table, missing's not there. What gives? All right. So let's do table, the help file. So help. So use NA by default. So if you see anything like this in a function, most times when it says a bunch of options, the first one's the default. So use NA equals no, if any, always. So if any, so there are NAs, but it says I don't want you to keep them. So that's the default in table, right? So if you wanted to say use NA equals if there are any, we've done that. You say tab. What's the length of the table? You see that there's 9 missing values. We see 8, so we see agreement. So again, tidy is a good function to try, at least on a lot of things. So if we say tidy, what it gives us back is a data frame where it says this is the variable, it doesn't necessarily name it, this is the frequency. So if you want to use fun dplyr functions, dplyr verbs on that, that's one way you can do it. So I saved the table out. So this right here is at least one of the most compelling things for Stata users and SAS users. I can now save out objects, summaries, statistics, whatever, things I actually want to report into objects that I can then manipulate. Right? So if you worked in Stata, for example, I think in the 620s they're like, find this table, copy and paste it in Excel, and then we'll make like a nice table. And that is scary to me a little bit, because you have to copy. If you have to copy and paste something to get something out, that's a little bit worrisome and also very hard to reproduce, right? So the fact that you can get tabulations and that kind of stuff out and manipulate them in code, it's very appealing, at least to myself. I don't know. If you like copy and pasting, then that's for you. Yeah.
Which package is tidy?
Tidy is in Broom. So again, if you just help tidy, you'll see up here that it says it's in the Broom package. So if you just loaded dplyr, for example, you might not have access to it, but if you loaded up the tidyverse package, you should have. It should be in there. All right. Any questions for moving forward? Great. Get out of here. All right. So here we're just going to we're going to take that overall data set. Remember, it's got all the bunch of years, a bunch of states, a bunch of different populations. So we're just going to subset the data to say I want the smoking status variable or value. I want it overall, genders or sexes. I want the current smokers, and I want it for middle school students. Okay. So I'm going to select that subset out of my data, and I'm just going to only select the year, the location, and the data value. It's the way this data is set up, and it's got multiple different types of data in there. In this case, we're looking at the, I think it's percent of current smokers, or percent of that population that are current smokers, right? So here, I'm just showing the head. So again, it's for 2015. We have different states, and we have that smoking variable. So, group by is another dplyr function. Probably the one of the most powerful and most useful ones, other than the verbs themselves. So group by allows you to group your data by other variables. So in this case, I'm saying sub-YTS is grouped by year. So there's multiple years in this data set, and I want to group it by year. You can group on multiple variables. I could have put a bunch of things in here. Note, though, the grouping sometimes can have, at least the way it's reported, have some sort of order. Or at least the way it calculates certain things. So, for example, if you wanted to get, if you had longitudinal data on multiple patients, you could group it by patient and then do means and get the patient means of some variable. If you had it on regions, geographic regions, and you wanted to do it by that, if you had subtypes of treatments or whatever, group it by whatever you would want to. And if we look at the head of this, it doesn't look any different. For the most part, except for this one line here, groups. That's all. So it says groups and the variable. So it doesn't change the data in any way. It gives it a different attribute, but it does change how the functions operate on it. So if we use that summarize command like we did before, so summarize allows you to summarize data into some sort of summary statistic, or some sort of summary value, or Anything that condenses usually a bunch of values to one value. So in this case, we're going to get the year average, we're going to take the mean of that data value, and we're going to remove any missing values in that data set. And what you get out of that is the average percentage of smokers over time for middle schoolers, right? Thankfully, as you see, in 1999, it goes way down in 2015, so you see there's a market drop-off in that. But this calculates this mean on this value over each individual year, because that's the way the data is grouped, okay? Does that make sense?
Why, when you go back to the previous slide group by, why are you not including the NA.RN?
So you're not. So all I'm saying is group the data. It's not calculating anything. It doesn't. So if there is a year that is NA, that'll be a separate group, right? So it's just saying make groups, kind of, in the background. And it's not actually making groups, but what it says is it's saying whenever you do some statistics, whenever you run some of these dplyr commands, certain ones, you want to do it by group, right? So really quickly, let's see. Let's see if I can grab this. So if I didn't do that, so if I'm just loading the data in, I'm getting the exact same data set out, and I'm not going to group it. So if I say summarize YTS mean data value, just gives me one number. If I say, what was it, average year or something like that, I called it. Just gives me one number because it says over the entire data set you want to summarize this. So without grouping it, it just gives me one number. But after I've applied group by, it does that statistic over each group, which in this case, the groups are years. Okay? So many times in data sets, you want to group by something, calculate something, and then maybe regroup it in some other way or some other sets of groupings or something like that. Or for example, you want to group the data and you want to add, let's say you have longitudinal data on patients and you have their blood pressures measured, 5 or 6 times. If the windows are, if the sun is bothering you guys, we can shut some of these blinds. Okay. Andrew, I'm going to enlist you on that.
Right there.
I am right there, yeah. I'm talking. Anyway, so for example, if you have like blood pressure measurements, like 5 blood pressure measurements per person, and you want to add a column, you want to mutate your data, right? You can add a column. You can group it by patient, get the average blood pressure measurement, and add that as a separate column. But it's going to group it by individual patients and get the average blood pressure and add that, right? And the average blood pressure is going to be different for each patient, for example. But after you've done that operation, maybe you want to group it by treatment group or something like that and do something else. So the way you remove groups is just ungroup. Okay? So you can have grouped your data, done something to the data that relies on that grouping variable, and then to get rid of that grouping, you just say ungroup, and now you no longer see up here that it is grouped. Okay? So generally the kind of workflow is data set, group it by something, perform operation, ungroup the data set. Okay? Again, this is just a little bit easier. So before I said I assigned the data set to the group, I said sub YTS is grouped by sub YTS by year, right? On this slide, I said group by. So this slide, I'm just showing you how to do that all in kind of one kind of operation. You pipe this data set. So the way the pipe is kind of thought of, or the way you kind of say it, you take this data set and then, so the pipe is kind of an and then. Take this data set and then you group it by and then you summarize it to get this average data value out. And it gives you the exact same result that those individual steps that we showed you before, but a lot of times at the end of this, you may want to ungroup it as the very last step. It's not going to change anything about the output other than it's not going to be grouped anymore. Summarize, after you kind of condense the data over groups, the groups are removed by default. Okay? So those who work in the Stata world, this is kind of like collapse. So if you've ever collapsed a data set. But again, we have, in this data set is the year averages, but in this full data set, we still have the entire full data kind of somewhere else. Okay? So, summarize is not the only command. You use group by with. Mutate, you can also do that like we were talking about. So you can group it by year. You can mutate, give it the average data value. So here, up to here, we've added a column. We've not condensed our data in any way. We calculated the summary, and then we added it to the data set. And then we arranged it by the description and the year. So for example, record 1 and record 9, this is the 2000 data for Alabama, this is the 2000 data for Arizona. They both should have the exact same average for that year. Okay? Because we grouped it by year, calculated an average, and then for every single year that was 2000, it should have this average. Every single record that is this year should have this average, and so on and so forth. So we haven't changed the data around. So we've added a column to the data set, but we've not compressed it in any way. All right? So for example, if you wanted to say, this is the group mean, right, for something, and you wanted to calculate a z-score compared to the group mean or something like that, this is one way you do it. Right? This last part is just sorting the data so we can actually see these two records. But also, note, the groups stay. Summarize, it compressed the data and said, you don't need these groups anymore. You've already compressed it to now one number per group. What else are you going to do? So by default, summarize removes the groups, but it does mutate, for example, does not. So this data is still a group data set by year, but we've just added another column. Yes?
Can you say group by year and gender?
Yep.
And just have the
It would just comma, whatever you want.
whatever.
Group by 100 variables. I mean, usually your data is not 100. You probably wouldn't group by 100 variables, but yeah, you can group by multiple things. All right, before we move on. So there's both instances I just showed you. The data was grouped, and you both summarized and got a mean value. But in one instance, it collapsed the data down into the groups and the statistics. The second instance with mutate, it didn't collapse the data down, it just added a column. Is that clear? What happened there? All right, so now there are a lot of other functions you can do, which are helpful for summarization, right? N is a function in dplyr. And so what you do is you group it by year, you summarize, and you just say, how many records? Count. So N is a function that counts things, right? And if we just look at the head of that, this, at the end of the day, is just a frequency table, just in a different kind of format. So if we did table year, table, sub YTS $year, we would have got this same data in a table, right? Tally is just shorthand for this operation. So tally means tally them up, essentially do the frequencies. The nice thing about doing it in this way, in some respects, is you might not just want the ends, so you can add a bunch of other summarizations in this function here, right? We want n, we want the mean of this, we want the standard deviation of this, and so on and so forth. Okay, I'm just showing you that the function n can do this, but if you really only want to do the frequencies, tally is a nice shorthand way to do it. All right. All right. Questions before lab 3.
Can you give an example of that last thing you explained on the board?
Yeah. So why don't we start the lab, and I'll bring one up. All right. So we're doing part 3 of the lab. Tidy's in it's in Broom, but sorry, I may be my fault. Okay, so the Tidyverse package contains a series of packages. I thought Broom was in there. It's not. So you have to load Broom if you want to use the Tidy package, the Tidy function. Sorry. So you just say library Broom.
That's why all the answers are in the lab.
Yeah. I downloaded. This is not the. Yeah. So it'll take about 10 minutes, or 8 to 10 minutes. We'll do it 9:20, and then I think wrap up part 4 relatively quickly.
Yeah, I think if you close your heart, it'll open back up.
Yeah, I have to.
Yep. Except this is not yeah, sure.
Sometimes you won't take it.
So that's the plus. Yeah, you press up the. Yeah, so flip over the mouse.
I'll do it.
Yeah.
Thank you.
It might not be in the PDF update. It's definitely HTML.
Oh,
Just- Yes, and I wanted to group it by project type, not like. See, right now, like every level, every group is like one of them. Like, who's asking which category has some trips attributes? So it's like, yeah. Okay, no worries. It's cool. So it's just one injection that instead of looking at it, if you just look at this, basically YGS go up. So just take in order to have those columns. You go up a little bit right here. This already has a year location and data value. So it just is adding. It's just adding the numerical your average to that.
Okay.
So you don't need to like tell you to select function of the page. Just return all the columns plus the column you had. So you just no, it'll have like 17 times 50 groups. You can try the code and see what happens. Right. So you'll have like each category. Right now there's 7 categories because there's 17 years. But if you group by year and location, so that's how many years there are times the number of categories, locations. So basically make all pairwise combinations of years and locations. So I'm also not sure. It might be that's an entire data set. That's a. I don't know if the actual summarization. I don't think it should. So that we're reordering it. If you don't arrange it by location, it will keep it arranged in the original order. Specific. Yeah, it will be. It will show. It will order by location. That's a good question. Yeah, but yeah. So you have to make this. Functions are basically the columns. Data frame, wow. Sometimes you get it. Sometimes you do. You would just say so.
you're good. I was just. Yes.
So I'm trying to
Yep. Like we're not like average. Only thing is,
Okay.
so this, that's saying that this
Okay.
so that vector
Yeah.
is you're saying this variable is combined.
Okay.
So let's try that.
Essentially.
So, again, people are smart,
Yeah.
but they allow you to do some things. So they say that's a kind of picture. So it allows you to do some things where you don't have to look like quotes, where you have to do that. So what it's saying is it's treating the same way. So that was treating
Okay.
so just calculate me. That's why they were all.
Okay. Awesome. Thank you.
All right, let's go over some of these. So which bike lane type has the longest average bike lane length? So we're going to do it in 2 steps. I think a lot of you, did something like this. Sub-bike group by bike type. Right? So again, we're grouping by the type of the bike. Right? Or bike lane. And that's okay. You don't necessarily have to you don't have to reassign it to something new. We could have just said bike is this, but just be aware that bike then will be grouped. So I'm going to keep it as bike, so I'm just reassigning bike to this grouped version, and then I'm running summarize bike mean length. So, a couple things about this. I grouped the data set. I said summarize it, and I want to take the mean of the length variable. This is not the function length. This is the variable name length in that data set. Okay? So, note, we get the different bike lanes, we get the lengths. At the end of the day, the answer was side path, right? That's the one with the max. So, you'll notice if you don't assign this to a new name in the variable, I don't know if it's easier to see. I don't know. A lot of people are trying to see in the back, so I don't know if you can indicate how it would be easier to see this. Let me know. If I pull it up, pull it down. So if you don't assign this anything, it's totally fine. It calculates it. But it gives you this name in the output. It's like mean length. That's totally fine. If you want to call it whatever, that's when you just say, just like in mutate, when you're defining a new variable, you just say, this is the new variable's name, and I want it to set it equal to this. Because there are no missing values in the length column, we don't have to say na.rm, but if we do, we'll get the exact same answers. So first, we grouped it by type, and then we summarized it. So we could have also done gotten the exact same answer. Notice also Hadley is from New Zealand, so that's going to be relevant a little bit later. He summarize and summarize, depending on how you spell it, are the exact same function. Doesn't matter. That is going to be relevant because for some reason, when I've gotten indoctrinated in this plotting function, in the plotting package ggplot2, I now only when I program in that package do I spell color with a U, and everywhere else I don't. So later you can spell color with a U or not. It's going to be exactly the same thing in that package. Yes.
How could you order that list?
So cheat sheet. How do you sort data frames? What's the function? Arrange. So let's say arrange. So this is why it's so we're going to use descending. So this is where it becomes very useful to actually name it something, right? So if I call average, we're going to do that. So side paths at the top. Then you can do a whole bunch of other things you can use. So head is useful for viewing, but also you just say head 1. That's just going to return the first row. So if you wanted to do that, it'll just give you, it'll run everything. So now, as you see, like the operation doesn't become like, I'm just adding more kind of operations to this as we go along with the pipe. So grouped it, summarized it, we arranged it, we sorted the data by decreasing average, and then I just said, I want you to grab the first one. Yes?
Curiosity, why does this work without the type operator? Like if you were to do arrange, describe, like $sign, average.
So arrange and all these verbs are all with respect to a data set, a data frame, not vectors. So what you're saying, so for example, when I say arrange bike average, or let's say bike length, it's going to say I have no idea what you're talking about. Is this what you're referring to? So that is because it's saying, this isn't a data set, I don't know what you're talking about. I don't know how to sort, I'm not sorting vectors. There's other functions for that. If you want to sort a data set by a variable. So the first argument every time is the data set. So that's what we're piping in. We're saying data set into the group by. This returns a data set into the summarize command. Data set into a range. Okay? So if you did this, it would run. So this will give you the bike lane data set back with, it's sorted by length in increasing order. Does that clarify things a little bit?
It didn't work, but I assume.
This didn't work? What? Well, are things named?
It's because I did average the name of the data.
So, to be clear, when I run this up here, I didn't reassign it to anything. So because I didn't say bike equals this, right? If I say like summarized bike is equal to this, and I run summarized bike, I'll take out these lines so I didn't arrange anything. Summarized bike, and then I say average, it'll work, but when I didn't redefine this, it just showed me the output, right? So again, the pipe and all that, it does the operations. All it does is make it more readable. But if you want those things to stick, or you have to reassign it to that data set. Does that make sense? Yes? Yours is being rounded up. What does it say up here? It says double. Same. Interesting. Run this command. Options digits. See what comes out of that. That is strange. I don't know why that would be. If you you say summarized bike or whatever you called it, and then average, and print it out, what comes up? Just rounded numbers? Where you just grab that column. So whatever you call the summarized data set. Do you get decimals or no? Okay, yeah. Take your time. I'm going to move on to category, and then we'll get back to that strange thing. I don't know why that would be. So, same deal with project. The only difference we'd have is we now just change the grouping variable. Okay? So if we looked at summarized bike, without sorting it, we can sort it. We see the maintenance line is the max. So now we can also use you can also try filter. So again, this data set, we've summarized it by different projects. We can use a filter function to say, which average is equal to the maximum of that column. Okay? If we do that, that's another way. Instead of arranging it and then grabbing the first element, this is a totally different way, but a different kind of thought of operation where you say, we've summarized the data and now we want to filter it where we want to check which one's equal to the maximum. Okay? Does that make sense? So we're calculating a statistic over something. We're not summarizing it. We're just saying which one. We're just saying give me trues or falses if it's equal to the max or not. All right. Last one. So, what was the average bike lane length per year that they were installed? Set bike lane date installed to NA if it's equal to 0. So we give the command here. So we say reassign date installed if date installed is equal to 0 to missing. Okay? What was the average bike lane length per year? And so we're going to do the same thing, just group by date installed, and see that most of the installations were in 2006, so the highest one, or the average bike length per year. So we just want that information. So we will. So I'll show you in a minute how to do the same operation that we did here, but in a dplyr way. So bike date installed. So there's a function called if else in R, which you ask for. We have slides on that in a minute, but I just wanted to show you. This is one way you can do it. So this line hopefully is straightforward, or at least straightforward is maybe not the right word. You understand this line, right? The date installed, you find the cases where it's 0, and you set all of them to NA. Okay? This line here. This line up here is saying mutate this column. You could have created a new column. It's totally fine, but this one we want to overwrite it. We're going to say if else. If else takes a logical condition, right? Is the date installed 0? Yes or no? If yes, give it a value to replace it with. In this case, NA. If not, keep it as is. Okay? So these are two different ways to get the same exact result, where that data set, that column date installed now has an NA. So did you have rounded numbers when you printed it out? Sorry, well, I can't. Okay, well, I'll take a look at that during the break. All right. So, any questions before we move on? All right. So now we're going to do something that's at least more fun than just looking at numbers. We're going to do a little bit of basic summarization via plots. So, these are some of the base R plotting functions. I am not going to go over them. So, plot is probably one of the most useful functions in R, period. I'm going to show you how to do plotting in the ggplot way, and we're going to use a function called qplot for quick plot. But plot exists and can plot a lot of things. Box plots, they make box plots. Hist makes histograms. We will show you a little bit about that. And density makes kernel density estimates if you plot them. Okay? But, again, I'm not going to show you a lot of the base R ways. We're going to kind of show you in one conceptual framework how to do it. And the way we're going to do it is ggplot2. It's very popular and powerful using the grammar of graphics. That's where the GG comes in. Okay? There was a gplots package. There's no ggplot package. It's only ggplot2. Okay? So we're already there. There's no ggplot1. Don't ask. It doesn't exist. So we'll use the qplot function for most of the basic examples, most of the examples in general. So the qplot function takes in x variables, y variables, a data set, and a whole bunch of other arguments. So for example, x limit, what are the limits of the x-axis that you want to plot? Y limit, what are the y limits? X lab, what is the label for the x-axis? Y lab, what is the label for the y-axis? Don't look at the definitions. I'm just saying you can define them to be whatever you want. Main corresponds to what do you want the title, the main title of the plot to be. And we will be changing this thing called a geom, right? So it's just saying, what do you want to plot? So we'll get into the nitty-gritty. We'll show you scatter plots, line plots, all that fun stuff, spaghetti plots in a minute. So any exploratory data analysis, plotting is an important component of it. We're going to be doing some of the basic ones. We'll go over how to format them in an additional lecture to make them like publishable, nicer. But I think one of Andrew's advisors and a faculty used to be here. One of the biggest things he's always said about plotting is it should be quick. You should be able to do it fast and iterate frequently. Right? So I'm going to load the ggplot2 package. This, undoubtedly, though, is definitely in the tidyverse package. So if you load it up tidyverse, it's in there. We're going to use qplot. The data set we're going to be using is the MT cars data set. We're going to plot on the x-axis the displacement, the y for the miles per gallon. By default, qplot makes a scatter plot. Okay? So before we go on to other types, any questions? So again, like dplyr, we are not putting quotes or anything around that. These are not vectors that are in your environment. These are columns in this data set. Okay? Scatter plots. So I didn't show you the base R graphics, but it is funny because I think a lot of people get pitched on R and be like, the graphics are beautiful. And then you see something like this and you're like, right, scatter plot, great. Any system, it takes a lot of time to make a nice, publishable, well thought out graphic, regardless of the system, regardless how many tools you have. ggplot2 makes it, I'll say, nice-ish by default. That being said, I can spot a default ggplot2 graph a mile away. I've gotten work from students, I've gotten work in papers, and I'm like, this is the default. You didn't change anything. You didn't customize this. You didn't change labels to be better. This is too small to see. I don't know how your vision is in the back of the room. That's not great, right? When you do when I see presentations or talks, like I can't read that from back there. So that being said, that's why I call them nice-ish, right? Because they're not done. Okay. We're going to do, we just changed the data set around. TB data set, we want to plot them for 2000 average. We changed one argument, the geom. So here we, instead of the default, which is a scatter plot, I want to plot a histogram. So I don't have to have a y variable here. I can, but I don't need one. A y variable will plot histograms by other variables. But here, I just do this and change geom and say, I want to do a histogram. It says, okay, do the before 2000 average, do the counts on the y-axis, and you got a histogram. Okay? Same thing, just change up the data set. The geom we changed as well. Now we're doing a line. Okay? If I didn't put line in there, again, they would put points on there. By default, it would be a scatter plot. But here we just say, nope, I want a line plot. Can you have multiple geoms? Yes, you can. You can have points and lines and dots and stars and whatever you want. So another one that's pretty useful to get an idea of how your data set looks like is a density. So again, we're going to plot the data value. The data is this. Geom is density. So instead of doing a histogram, we essentially do a smooth histogram or a kernel density estimate. That's the kind of overall shape of your data. Mind-blowing, I'm aware, right? It's a big... So, box plots. Yes?
Is there a place where we can see all the different geoms that are available?
Yeah. Yes, I believe.
It's also on the online guide.
Yeah, so the online vignettes for ggplot2. So again, one of the ways you can go there. So if we say browse vignettes ggplot2, is it not in there? Or am I? What's just the ggplot2 website? I think he.
It's docs.ggplot.2.
If you say ggplot2, there's a documentation page which kind of talks about all of the fun things. So on the first page, so there's a bunch, right? So we do maps, points, polygons, QQ plots, violin plots, and if you click on like error bar things, it talks about that. It talks about different things in there, and it gives you examples. All right. So here we're plotting on the x-axis the location, y the data value. This is the smoking data that we had before. You'll note here names for the states are all jumbled together, but we changed the geom to be box plot. One way you can change this around, so I'm talking about this and this code are the exact same code. The only difference is I flipped the coordinates. Word flip. So I said, we got each plot by state. Actually, I want the state on the y-axis. I changed the plot around. Now you can actually see the data value in each individual state. Okay? So this shows, for example, some outliers and these certain things. You can sort the data. If you had sorted this data in a certain way, we'll talk about factors a little bit later. You'll be able to order them by like the median or something like that. Okay? So there are other summarization. Matplot, you do a scatter plot of two matrices. Pairs, which do a pairs plot. There's a package called ggally. I think that's how you say it, or ggally, I don't know. ggally, if you say gg pairs on the data set, it'll give you a scatter plot matrix with correlations and all this fun stuff on there. So you can see that. I would not necessarily. So this data set, remember, is subsetted from 1990 to 1999, and we put that in there. We didn't put the entire data set in there. If you put in a huge data set, this thing's going to be more or less impossible to read, and this is probably the extent of it. This is 10 by 10, which is pretty big, right? But it gives you correlation metrics. It gives you the density of each column. So this is the density of the data values for 1990, 1991, and so forth, and these are the scatter plots on there. There's different options to add lines. I don't know how useful that is, but some people like to use these, give them an idea of their data. The pairs package, or the pairs function in R does that, but it does it, I think, a little bit worse. It gives you a little bit less information. So, lastly, we're gonna go to the lab and take a break. So the conclusion, base R's got a lot of things. Has a lot of apply statements that allow you to do things repeatedly over columns or rows. dplyr has pretty much more intuitive syntax, I think. And group by is very powerful, especially, if I spelled that right, especially with summarize and mutate. Right? So I will say base R still has some good things for quickly summarizing all the rows or all the columns of a data set. So col maxes or col means, row means, a lot of times you're going to do that. There is a package called matrix stats, which really expand those functions. So there's col medians, col standard deviations, col IQRs for interquartile range, and a whole bunch of other functions for cols or rows of an entire data set that you want to summarize. All right, so we're going to go to lab 4 and kind of take probably a break until about 10. I think these are relatively straightforward. You have the answer, so we'll probably reconvene around 10 a.m. Okay. I want to see Andrew.
Yeah. Yeah, so it's what's the code itself? You run it. Like in the script.
78 is, see, like there's an extra pipe somewhere. There's an extra, I'm not sure I shall be code chunk. No, like, I think 77, 78 are like two different. Are they supposed to be two different things, or? See, yeah, because you average equal bike isn't really, it's not like a pipeable thing. You might have to just delete, if you just delete that line of code. Well, or just press enter after 77.
Yeah.
Just delete, just like delete the pipe and press enter.
So it's,
So that might, if you just run 79. Well, because you're passing, like, there's no way, it's like assigning something within the pipe and it doesn't, it doesn't really stop the code. Like, there's no, it's not pipe.
so you installed, so you didn't have to be.
So that part should work.
You.
What's NM?
I don't know if I could answer.
So was that last
Yeah.
thing? Oh.
That's, maybe if you shut down one and restart it, so
You can't, it's not assignable. Like, I don't think it should have actually.
I'll
Yeah. I'm not sure. Oh. So yeah, it was basically hanging, it was looking for another line. So yeah, this code works. You just, this part, because this part was already, because there's no, I don't think there's a data frame called project.
So it's giving you all of the.
So like here you're saying group by data frame called project by type. There's no, so like here you would have, if you wanted to group this by code.
So if you filter it,
This should
so
work.
that is the
Right, and then like this works. So you have to, you could, again, like these two, you could either replace these two commands with this part, or so basically just chain two of them together where you needed like a break.
So there's two things outside.
As a function
It's
of,
relevant to that.
it's basically saying like, let's do the length as a function of time, or stratify. So the last day we talked about like, basic statistics, like that's how you specify regression models. So y is a function of like x and z. That just pivots the axis label. Like you'll see if you run the first one, you run the second one. See it pivots the, it just is the relative spin on the axis. You can press it, there you can flip through the arrows, but in base, yeah, like you can't do that in base R or studio. Maybe you put it in 5 minute break. those cases where actually, so you say, so this I had an illustration was on that's a team. It's own. So if you try to use the environment, okay. I mean that'll work. So again, if you want to over so this command here isn't actually here you're saying you take understand that's the calculating so if you grouped it so you could do
Sorry, yeah. So, you might need sub bike there. Like length is TH. Then if you wanted it grouped by the type, you would need to pass the sub bike. That's why like is the data frame name. Like right now you're asking to summarize with the bike from the data set, but not the one that's grouped by the type. So you just need to, instead of saying summarize bike, you need to say summarize sub underscore bike. Yeah, so that you put that in there, sub underscore bike. Run that. So it's like one breaks it by group, because like you can find it in the line before it. So it just depends if you want the overall average or the one stratified by the types. Whatever the stratifying variable is.
So that again is just going
Lowest. That's what I was trying.
You could pass out the ones, but that's kind of stop.
Yeah, so like, is this in that? So you can take the 50 states, and you say, is the state in that state? That should be percent on percent.
They're always significant, it's not so much. Just try one child. Just try this part. So, one child died, dollar sign. Just try that. It's not. Try that.
You have to do.
You do.
Yeah. Summarize assumes you're giving it a singular value back when you summarize it.
You can just try to see one child first. Don't without the type. Just the types makes it easier.
What?
They want like multiple summaries.
No,
Okay.
not
That's
really.
fancy. Yeah.
I'm going to be talking about this, but I do want to bring up. So on the website, we were talking about something about reading in the data set, the Kaggle data set. So if you go in the live code examples, there's this file called read_CSV specification. So I'm going to go over that really briefly before we go over the lab because I want to talk about this a little bit because we talked about reading in data sets and what happened with some of those cases where it had some problems. So if we had this Kaggle data set and we read it in and we see the output, it said, this is the specification, this is how the columns are defined, all that fun stuff. See the specification, it says, warning, had some failures, right? So see the problems for more details. And if we said problems, we saw that the row, the column, and it had some problems with this vehicle B cost because the first 1,000 records, which is the default it looks at, it says, hey, they're all whole numbers. I think this column's whole numbers. Okay, great. Now these have decimal points, so it says, hey, that's not a whole number. I don't know what to do with you. So it said it's missing. So another way you can do that is just tell it, look at the complete data set, right? But that takes a really long time to read in. The best way and the most straightforward way is if you either specify all the columns, but that takes a lot of time. That's not really the best, I think the most elegant solution in a lot of respects. But if you say this is the only column that's problematic, you would say read CSV, wherever the data is, col types, and then you give this col specification, and then you say this column is a double. So we're going to be talking a little bit about, the differences between whole numbers, which are sees as what's called integers, or numerics or doubles, which have decimal places, right? So they're floating points, or whatever you want to call them. They're pretty much, they can have fractions, right? So if you run this command, you should see, this is relevant to the homework, right? So this is up on the website. If you see this, you don't see any errors or warnings. If you say problems, cars, you should see a table with 0 rows and 4 columns, which means there are no problems in this data set. So for your homework, I would say use this function in this way to say this specific column, don't treat it as a whole number. Treat it as a number that can have decimal places. And that's fast and straightforward, and you don't have to do something like very kind of egregious where you specify every single column type. But if you did, this would be one way you could do that. For example, some code books and some other things you have from some online sources or large databases, they tell you the type of each single column, and you can use that information. But here, probably the most straightforward, the simplest, still reads it in really fast, and you have the data set with the full data in there. Okay? So look at that piece of code to read in the data set for homework 2. All right. Numerically, describe the distribution of bike lane lengths. So if I say quantile bike length, I get the quartiles, right? So I get 0, 124, 200, 341, 3749. So one, you should see 2 things. Something we already talked about. Some of the lengths are 0. That doesn't make any sense. 2, the maximum length is way, way bigger than the 75th percentile, right? I mean, that's almost 10 times larger, or 10 times longer, right? So, if we want to do a histogram, we could say hist bike length, or qplot x is length, data equals bike, geom equals histogram. Well, let me do it without the geom for now. So if you only give one variable, it assumes you're doing a histogram. If you give it 2 variables, it assumes you're doing a scatter plot, just by default. Okay? We could have also said geom equals histogram, but as we see with this data set, it's highly skewed to the right. There are some very long bike lanes in the city, whereas most of them are around, 250, 300. Okay? So this is the first time I'm going to show you a base R plot, hist. Sorry, I was trying to run something else. So this is the default in the base R. Yeah. So again, if we showed you base R graphics, you'd say, "Oh, look how great the graphics are in R." Right? Like, what an illustrative plot. No, so you can change the bins and all that kind of stuff. We'll show you that in visualization tomorrow. So, describe as above. After stratifying by type, then number of lanes. So, one of the things you should note, if I say bike group by type, summarize, quantile, length, it's not going to like it. So by default, summarize wants you to have one number to summarize out. Either a mean, a median, all that kind of stuff. So either you do something like Q0 is quantile, and you say probs equals 0. Q25, 50, 75, 100. We'd say 0.25, 0.5, 0.75, 1. If you do that, each one of those returns a single number, and you get the quantiles for every single different type of lane. That's it's not the best sometimes. It's not great. So there are other ways that we will show you a little bit later that are a little bit more advanced. I don't believe you need the dot. You may. Sorry about that. What is it? Dot.
Yeah. Plus a T, I think a T somewhere. That's how you just got the access. You don't need to summarize, I don't think.
Oh, yeah. Oh, let me see if I just tidy it. Yeah, tidy. So there is this function called do. So, sorry, let me go back to this. So again, summarize. It's great for what it does, but it's rather limited in the sense that it wants you to return only a single number for each one of these. Okay? There is a function, again, that's a little bit more complicated called do, which will allow you to say, okay, take this data set and put in something that returns a data frame, and I'll put it together for you. So you group by type, you get the quantiles, right? But you have to return a data frame. Tidy will do that, and do allows you to do this. Again, this is a little bit complicated. I would say, if I were you starting out doing this, I probably would say, how do you do quantiles and dplyr and this kind of thing? And this is pretty much what the help file will come up to be, or the stack code will answer. You could also do, you could also transpose the data. We didn't talk about that. So this is a different way. Before, each different row is a different quantile, right? So we had the types, the names, and X. If you transpose the data, you'll have a different column for each one of the quantiles. It depends on how you want the data out.
Again, this is like really advanced.
Yeah.
What if you don't get it? I had to look it up on Google.
Yeah. So I still owe you an example. So before I was saying that, I mean, this is kind of the example we just had. We can summarize multiple things. But before, we were saying, what if you want to summarize and have multiple things in there? This is some way you want to do that. So maybe you want to summarize the number of observations per year. Maybe you want to get the mean of some value per year, the standard deviation, and then this will make sense in about a minute with missing data. There's a function called is.na, which will come up true if it's missing, false if it's not missing, and then we can add those up. So this is getting the mean, this is getting the standard deviation, this is getting the number of non-missing observations. This is saying, is it NA? Yes or no? This exclamation point flips it, turns trues to falses, and then sum adds them up. So this is saying, how many records are not missing? So how many records actually went into that mean and standard deviation? And I'll post this on the website. All right. So Andrew's going to move on to data classes. Yeah.
You want to do, like, say, a box plot that's divided over multiple variables. Like, say you have a quantity that you want to divide out by, like, say, age group and gender.
Yep.
Can you do that?
So those are what's called facets. So if you look at the, so where do we do this? Okay. So qplot, x is length, data is bike. Facets, it's a little bit different way of project. Let's just say one facet for now. I think I might, let me just zoom out. Zoom. I want to do histograms by each different project. So we'll get to that in the visualization, but in the ggplot2 terminology, it's a facet. And you can have multiple facets where you'd say like type, type project, and then once it comes up, you'll have if each project has a different type, I don't know, there might be a lot of these things. Yeah, so like these are the different projects, these are the different types, and it does the histogram for each one of them. And there's ways you can drop ones that don't exist and stuff like that. Okay, all right. Mm-hmm.